Hello everyone, welcome to the new video lecture series Design of Reinforced Concrete Structure. And this series is basically based on IS 456 and I hope you will be familiar with IS 456. It's the Indian National Building Code. In this video lecture series, you will learn design of different types of structural elements like beam, column, slab, footing, etc. First take a look what we are going to cover in this lecture. In this first lecture, I will explain you the objective of structural designing and the process of designing. Then the difference between plain concrete and reinforced cement concrete. After understanding the concept of concrete and steel, you will learn about some basic properties of concrete like grade of concrete, characteristic strength, modulus of elasticity of concrete, creep and shrinkage, and durability. And at last, I will explain you the properties and types of steel. Before going into detail, let's take a look what is the objective of structural designing. What are some basic requirements of designing? So let's start here. Suppose you have designed a multi-story building. In this building, the main material we use is concrete and reinforced steel. We know it very well. If we applied any load on a material, stresses induced in these materials. In similar way, stresses induced in concrete and reinforced steel due to different types of load. But in structure designing, these stresses should not exceed the critical values, and these critical values already written in Indian National Building Code. If stresses exceed the critical values, then structure will collapse. According to Disaster Management of India, on average 2600 people died every year due to building collapse. For example, in 2013, a 7-story building collapsed in Thane, Maharashtra, in which more than 70 people died. The main reason of failure was use of substandard construction material. Hence, the first point is strength of material, and we have to ensure that stresses induced should not exceed the critical values. After that, your structure is strong enough, but you have to check its stability. The building or structure you design may overturn, it may buckle or slide. You can see here a 40-meter curve of Altadanga flyover in Kolkata collapsed due to instability. Hence, the second point is stability. Overturning, buckling and sliding also be prevented. And third point is serviceability. Serviceability is usually a condition under which a building or structure is considered useful. We have to ensure the satisfactory performance of structure under different types of load conditions. For performance satisfaction, we consider some important factors like stiffness, deflection, impermeability and durability. We will learn about these factors in more detail in upcoming lecture. We have to design our structure in a way that it becomes more and more serviceable. Lotus Temple in Delhi, a reinforced concrete structure, it is completely durable under different types of hostile environmental conditions. So I have explained you the basic requirement of designing. The first one is strength, second is stability, and third is serviceability. Maybe you have some difficulty to understand all these points here, but you can learn them easily when you start designing after a few lectures. Now I am going to explain you the process of reinforced concrete construction and where the design steps lie. Suppose you want to build your own home, then what will be your first step? It will be a planning phase. It is basically carried out by architect or planner to plan the layout of your home according to your basic requirement, like your functional requirement, your aesthetic requirement, and most important, your budgetary requirement. Then start the most important step, the analysis and design step, which is basically carried out by engineer. Engineers select the most appropriate structural system to bring architect concept into reality. Then he estimates different types of load on a structure, and on the basis of these loads, he analyzes the structure for estimation of stresses. After that, he starts the structure design process, which we are going to cover in this video lecture series. Here we will design the actual proportion of the element, like their size and how much steel is required. Then we will check it, are the safety and serviceability requirement are satisfied. If it is satisfied, then we have to submit the engineering drawing, then start the construction phase. If at any level the requirements are not satisfied, then you have to repeat the process of estimation of loads and analysis of stresses. Hence, the most important step in construction process is structure analysis and design process. As I have already told you, the main material we use in construction is concrete and steel. Now I am going to discuss some basic introduction of concrete and steel. We know that plain concrete is made by mixing of cement, aggregate, water and admixture. Concrete is generally prepared at site itself, although ready-mix concrete and precast concrete are also used. We use concrete because its compressive strength is very high, but there is a drawback. Concrete tensile strength is very low, almost negligible compared to its compressive strength. If we applied a small load, beam will fail in tension and crack will be visible, and you can see here these cracks. It means concrete is weak in tension, and that's why we use steel to provide tensile strength. Steel embedded in concrete is called reinforced steel. The complete composition of reinforced steel and concrete is called reinforced cement concrete, also known as RCC. Steel usually manufactured in factories under controlled conditions. It can effectively take up the tension that induced due to flexural tension, direct tension, diagonal tension, and different types of environmental effects. These all are tension which induce in concrete. You will learn about this induced tension in more detail in upcoming lecture, but here you have to keep in your mind that steel is used to take up this induced tension. If we apply heavy load compared to plain concrete where we applied a small load, cracks are very thin. They are not visible, and under heavy load, steel bar undergo yielding and the beam will fail in ductile mode. It simply means that steel also provides ductility to material. And one more thing I would like to tell you, even we use steel to provide tensile strength, but its compressive strength is more than compressive strength of concrete. After introduction of concrete and steel, now moves to some basic properties of concrete and steel. Let's begin with concrete. The desired property of concrete are its characteristic strength, modulus of elasticity, creep and shrinkage, durability and etc. Before these properties, let's take a look on an important point, how to represent the type of concrete on the basis of its quality. We simply use the term grade of concrete to represent the quality of concrete. As I have already told you that the compressive strength is most valuable property in structure designing. This is measured by standard test on concrete cube specimen of 150 mm size. The quality or grade of concrete is designated in terms of number, and the symbolic representation is like for example M20, where M represents the mix. The numerical number represents characteristic compressive strength of concrete at 28 days, and this strength is expressed in megapascal, or we can say Newton per mm square. On the basis of different types of grade of concrete, Indian National Building Code IS 456 has described in three parts: the high strength concrete, standard strength concrete and normal strength concrete. Grade of concrete between M10 to M20 known as normal strength concrete. M25 to M55 standard strength concrete, and above M60 is known as high strength concrete. Now there will be a question in your mind that numerical value which is represent the characteristic strength of concrete, then what is the characteristic strength of concrete? This is a very important property of concrete. Concrete is a material whose strength varies from specimen to specimen. If we collect cube specimen from same mix, then they give different value of compressive strength in laboratory tests. Characteristic strength is defined as the strength of material below which not more than 5% results are expected to fall. If we draw a graph between number of specimens and characteristic strength of curve, it has been found that this criteria is satisfied if target mean strength, we can say it Fm, is equal to Fck plus 1.65 sigma. As you know that concrete shows some variation in strength, this variation is shown in the form of standard deviation or coefficient of variation. We can also use a formula. Coefficient of variation is a ratio of standard deviation to mean strength. The value of standard deviation is given by IS 456. According to grade of concrete, the standard deviation value for M10 and M15 grade of concrete is 3.5, for M20 to M25 is 4, and greater than M30 is 5. After understanding the concept of characteristic strength, now move to another important property of concrete. It is known as elasticity of concrete. We know that concrete is a brittle material. If you see the stress strain curve carefully, you will see that concrete is not only non-elastic, it's also non-linear, because upon unloading, it does not follow the same path. But if you see carefully, only initial portion shows some linearity. In this portion, we can consider the modulus of elasticity of concrete, and we know that up to the proportionality limit, the stress is directly proportional to strain according to Hooke's law. But in concrete, there are two types of strain. One is short-term strain and another one is long-term strain. Short-term strain is due to instantaneous load applied on structure, and long-term strain is due to creep and shrinkage. On the basis of short-term strain, the modulus of elasticity of concrete is called short-term modulus of elasticity. On the basis of long-term strain, we call it effective modulus of elasticity. Further, on the basis of short-term elastic strain, we have three types of modulus of elasticity. The first one is initial tangent modulus. It's a tangent from origin. If we consider the stress at any different point, then tangent at that point is called tangent modulus. And if we connect this point to origin, then the modulus is called second tangent modulus. All these are theoretical approach to find out the modulus of elasticity of concrete, and on the basis of these approach, there are some empirical formulas. According to IS 456, modulus of elasticity, short-term modulus of elasticity is EC is equal to 5000 under root FCK, where FCK is the characteristic strength of concrete. This formula is based on initial tangent modulus. Now move to the another property, the tensile strength of concrete. We know it very well that concrete is very weak in tension. That's why tensile strength of concrete is only 7% to 15% of its compressive strength. We can measure the tensile strength of concrete in three ways: direct tension test, splitting test, and flexural tension test. Direct tension test is rarely used. The main problem of this test is gripping. Due to gripping, the secondary stress is induced. If we talk about splitting test, it is an indirect tension test performed on concrete cylinder. It gives more uniform result compared to other tests. In this test, load applied on its side along a diameter plane. but we are going to emphasize more on flexural tension test. It is most commonly used test on a plain concrete of beam of breadth and width of 100 mm and length of 500 mm. The testing is done using third point loading method, which you can learn more detail in concrete technology. After applying the load, theoretical maximum stress developed on extreme fiber is called modulus of rupture. So there will be a question in your mind, what is the modulus of rupture? It is a maximum theoretical stress which is developed in extreme fiber, and this value obtained by applying the flexural formula FCR is equal to M upon Z, where M is the applied moment and Z is the section modulus of beam. This formula is derived assuming that stresses induced is linear, but in actual stresses is not linear, and modulus of rupture is greater than direct tensile strength. And here code also suggests an empirical formula for estimation the value of modulus of rupture. FCR is equal to 0.7 under root FCK, where FCK is the characteristic compressive strength. And you can see here a very important point. This formula is a relationship between tensile strength and compressive strength. I explained you earlier that long-term strain develop due to creep and shrinkage. Now let's try to understand the concept of creep and shrinkage. Actually, creep is a time-dependent component of strain. If we see the graph between time and total strain, the initial portion shows some instantaneous strain due to applied load. Further increase in strain at any time is called creep. Both types of strain, short-term strain and long-term strain, depend on stress level. Stress level simply means which types of load we are applying on structure. Increase in strain sometimes expressed in terms of creep coefficient, and this creep coefficient is the ratio of creep strain at time t to instantaneous strain. The maximum value of creep coefficient is called ultimate creep coefficient. Value of creep coefficient for design purpose is given by Indian National Building Code. For 7 days is 2.2, for 28 days is 1.6, and for 1 year is 1.1. If we remove the sustained load at any time, the strain follows this curve. This is the instantaneous recovery of strain equal to elastic strain. Further gradual decrease in strain is called creep recovery. You know that concrete is a brittle material. It does not recover fully, then rest is residual creep strain. One more thing here is that due to creep, the modulus of elasticity reduced, and we say this reduced modulus as effective modulus of elasticity. Here is a formula: ECE, effective modulus of elasticity, is equal to short-term modulus of elasticity EC upon 1 plus theta creep coefficient. Now understand the concept of shrinkage. Concrete become hard. In hardened state, the concrete shrinks due to evaporation. Due to evaporation, the volume of concrete reduces, and its reduction is termed as drying shrinkage or simply shrinkage. Shrinkage is similar to creep, shows some time-dependent strain, but unlike creep, shrinkage does not depend on stress level. When shrinkage restrains in concrete structure, it develops tensile stresses, and excessive stresses lead to cracking. There is one more concept related to shrinkage. It is known as differential shrinkage. There are two main reasons for this type of shrinkage: the temperature variation, or we can say moisture or thermal gradient, and another one is unsymmetrical distribution of reinforcement in beam. Due to differential shrinkage, the internal stresses induced, and the main result is come in the form of curvature and deflection of structure element. There are questions asked in competitive exam: what will be the effect of unsymmetrical distribution of reinforced steel? And the simple answer is differential shrinkage. The value of shrinkage that we use for design purpose. Shrinkage usually expressed as a linear strain. And Indian National Building Code recommend the value of shrinkage is 0.0003 mm per mm. Now move to the another important property of concrete, that is durability. So what is the durability of concrete? If concrete serves the purpose for which it is designed during its extended lifetime, then we call it durable concrete. But there are some factors due to which concrete durability decreases, and there are two types of factors: internal factors and external factors. Internal factors are the properties of ingredient we use to make concrete, like presence of alkali reactive aggregate or salty water. On the other hand, the external factors are the environmental effects. These two types of effects reduce the strength of steel and concrete, due to which its durability decreases. So how we can increase the durability of concrete? There are some effective ways to increase the durability of concrete. Number one, provide adequate clear cover to embedded steel. This is a cross section of beam, and this length from extreme fiber to steel known as nominal or clear cover. To protect steel from corrosion, we should provide adequate clear cover. Or another way to protect steel from corrosion is to use coated steel. To make concrete durable, IS code recommend to use of appropriate minimum grade of concrete according to environmental exposure condition. This is the table from IS 453, and in this table there are 5 types of exposure condition: mild, moderate, severe, very severe, and extreme. And here are descriptions regarding to every exposure condition. For example, you are designing a structure which is near the sea area, hence your exposure condition is very severe. According to exposure condition, you have to use minimum grade of concrete is M35 and minimum clear cover should be 50 mm. So you have to use this table when you design, so that you can improve the durability of structure. So here we have finished all the basic properties of concrete. Now move to reinforced steel. I have already explained you that steel is used to resist tensile stresses induced in concrete. Now let's talk about the grade and types of steel. We also use the word rebar to represent reinforcing bars. In India, the size of bars varies between 5 mm to 50 mm, but most commonly used are between 8 mm to 32 mm. These bars can be in any form, either plain or deformed. Plain bars have a smooth surface, whereas deformed bars have a lugs-on surface. These lugs enhance the bond between concrete and steel. If we talk about the grade of steel, we know that we use compressive strength of concrete to define the grade of concrete. But here we use the term yield strength of steel to define the grade of steel. And I hope you will be familiar with concept of yield strength. It's a topic of another subject, strength of material. So according to IS code, the specified yield strength can be termed as characteristic strength of steel, and we represent it with a symbol Fy, and this strength is also measured in megapascal, or we can say Newton per mm square. We use different types of steel according to their characteristic strength. The first one is mild steel bar. We use the term Fe250 for this bar because their yield strength is 250 Newton per mm square. These bars are less commonly used because of their low strength. Another one is medium tensile steel bar. They have slightly higher strength than mild steel bar. IS code also permits the use of medium tensile bar, but these bars are rarely used. And another important is the cold twisted bar, also known as HYSD bar, high yield strength deformed bar. These are the most commonly used bars, and you will find these bars in most design problems. And these bars have a very high strength. FE415 and FE500 are the some types of cold twisted bar we use in structural designing. Next is TMT bar, thermomechanically treated bar. These bars are coated with anti-corrosive film, and the inner core of the bar are soft and ductile, and outer core have a very high tensile strength. So these are some types of steel. Now move another topic, modulus of elasticity of steel bar. All grade of concrete have an initial linear portion of constant slope, and you can see here these are have a same slope, and that's why all of them have a same modulus of elasticity. IS code recommend here the value of modulus of elasticity is 2 into 10 to the power 5 Newton per mm square, or we can say megapascal. We know that yield strength of steel is where the steel starts its plastic state. You can find out the yield strength of mild steel very easily because mild steel have a defined yield point. But in case of HYHD bar, these bar don't have a defined yield point. So problem is how to find the yield strength of these bar. So here is the solution. The stress corresponding to 0.2% proof strain, or we can say if we take an offset at 0.002 strain, then corresponding stress is defined as yield point for HYHD bars. Hence, the total strain at yield point becomes 0.002 proof strain plus the strength find out by Hooke's law, Fy over modulus of elasticity ES. So here we have finished our first lecture. Now let's take a look what we have covered in this lecture. First of all, you have understood the objective of structure designing, that we must design our structure according to strength, stability and serviceability, and the process of reinforced concrete construction where estimation of stresses on the basis of load, and then we have to check the safety and serviceability. Then the concept of steel and concrete. We know that concrete is strong in compression and weak in tension. That's why we use steel to provide tensile strength. And complete composition of steel and concrete is called RCC, reinforced cement concrete. And after that you have learned the basic properties of concrete like grade of concrete, their characteristic strength, modulus of elasticity, where you learn the new formula EP is equal to 5000 under root FCK. Then tensile strength, another formula, the modulus of rupture FCR is equal to 0.7 FCK. Then creep and shrinkage and durability. And at last, I have explained you about steel, its size, types, and how to find the yield strength of HYHD bars. So in this first lecture, you have learned a lot of new concepts and formulas. Maybe you have not understood all of them. Don't worry, I will explain these concepts and formula in more detail when we use them during the